who was playing with and arranging for the Chick Webb Orchestra. Here's Sampson's...
In this video segment, we're going to take a look at how to assemble the electronics. Not a whole lot going on here. Most of the electronics are pretty standard. We've got a Raspberry Pi, a couple other circuit boards for an amplifier, a DC to DC converter, the display, and so forth. We do have to make a couple of small circuit boards for the rotary encoder switches, but beyond that, pretty basic stuff, but let's dive right in. Looking at the schematic here, you can see that the wiring of this whole system is really quite simple. Right now we're going to address the rotary encoder switches, the volume and the tuner switch. Now what we've got, as the Fritzing diagram shows here, we've got a perf board, perforated circuit board material. It's great for prototyping and little projects like this. The rotary encoder, we're going to have 3 10K ohm resistors on each one of these. Now the important thing to know about this perf board in its size, we've got to make sure that it isn't too big. If it's too big and extends down too far, it would hit the bottom of the inside of the radio. Right now at this particular size, it's 8 rows wide, and I think I've got it 12 columns tall. It just barely fits in there. So what I'm doing, I'm moving this wire, this black wire, that'll go up around this way. That allows me to move up these 2 resistors I'll be skipping 1 row, and then this row and this row is where those resistors will be. Notice how they're much closer to the rotary encoder here. So with that, that'll allow me to cut away material at the bottom, but I'm going to reserve that until after I get these components soldered on. Another thing that's important, you'll know that rotary encoders on a lot of switches that are rotary have an anti-rotation tab, and there's a slot on the inside of your radio that you'll 3D print that accommodates that. Now that has to be towards the bottom of the radio. And then this, of course, would also be towards the bottom. So make sure that you install this correctly. And to help with this particular brand of encoder, which I'll have a link for, there's 3 pins on the bottom, 2 pins on the top, and then you got your solder legs on the left and right, which we really won't be soldering in this particular application. So with this, I'm going to flip it over, and I'm going to get these elements soldered on here. Now some of these legs may become traces or little connecting wires on the bottom as I'm soldering them in place. Moving on to some of the electronics, here's the schematic for our radio. Very, very simple. We've got our Raspberry Pi 3, our 2 rotary encoders, our power supply or DC to DC converter. Our power supply is a wall transformer. Here is our audio amplifier and our 2 speakers. Pretty darn straightforward. The area we want to focus on are the 2 rotary encoders. Now the size of these in this diagram is bigger than what we can use if you count out the holes and so forth. Here is what the actual perf board is going to be, and I'm actually going to even cut off a little more, maybe 1 more row of holes along the bottom. I'm trying to shrink the height because this, as it's in the radio, wants to hit the bottom of the radio. Just barely fits right now. So if I take off 1 more row, should fit in there with plenty of room. When you're assembling this, the one thing you have to pay attention to, like most rotary switches, this has a anti-rotation tab on it. And there's a matching slot that is in the design of the radio case. So that tab has to go in that slot to prevent it from rotating. So with that, I've got it roughly right now 8 holes wide and I think 12 holes tall for the size. Now what we have to put on here component-wise is the rotary encoder and then 3 10K ohm resistors. And those are going to be used to pull these input signals high. And if you want to learn more about this, I've got a companion video for how to use rotary encoders on the Raspberry Pi. I'll try to remember to put a link down in the description for that. But what we're going to do right now, I'm going to solder these components onto the perf board, and I'm probably going to use some of the legs as traces or as connectors between, say, the resistor and the legs on the rotary encoder. As I solder all this, I'll probably put the video on time-lapse so you don't have to be bored to death going through all of this. But you're just going to follow along with the wiring diagram and make all the connections. Now we need to attach some leads to it. Now normally I would try to put a connector or screw terminals here that we can attach the wires to. But in this area of the radio, it's very, very crowded in there. So really the best thing to do is just attach the wires directly to the contacts on the back of our little circuit board. Now what you have to pay attention to, and this is if you're new to electronics and soldering and all that fun stuff, remember that we're looking at the circuit this way with the encoder switch up. When I flip it over, it's a mirror image. So this, now the red is on the right and black is on the left. This is our 0 volts, this is our 3.3 volts, etc. So you'll have to kind of keep an eye on that as you're doing this. But essentially, I'm just going to wire my red to right there. We've got our traces going back to here. I'm going to bring the black all the way up to here. Let me get something a little more pointy here, and I'll try to zoom in. No, that's as close as I can get. I'm going to bring the black to this leg, and then bring it back to the center leg. So it'll go up around here to this point, and then back to here again. And then we will have our, I believe I'll try to follow the same color coding, but we'll have a green wire, a yellow wire, and then a white wire. So that'll be the final connections. Just remember, this is mirror imaged to the way that the switch is shown in this orientation. First I'll tin the wire a little bit, and then we'll attach it. What I'm going to do is just strip off a little bit in the middle of this wire. That'll be up at that connection. Then I will strip off some at the end of the wire. A bit more. And that will be connected there. That one will connect there, and then it'll loop around back this way. Now I assume you're following along with the schematic to help make this easy for you. And one thing you're probably wondering, how come he's using blue wire? Well, I don't have white wire, so blue is my substitute. And in case I forgot to mention it, I also had to drill out these holes down here to approximately 70 thousandths in diameter, 0.07. That's a little bit bigger than a 1/16 of an inch. Probably in the metric world it would be about a millimeter, almost 2 millimeters in diameter, just short of that, about 1.75 millimeters. Looking at the schematic, you can see here where the 12-volt power supply comes in, and that would be via a female 5 millimeter by 2.1 millimeter connector, and that'll connect up to the input of the DC to DC converter. So we're going to put 12 volts in into here, and we're going to take that same 12 volts and route it over to the amplifier board. So I'm splitting it apart right here. On the output side, I got 2 wires soldered in on the board, and they're going to connect onto the Raspberry Pi. Now I'm going to violate a couple of my own rules here. First off, you'll know there's no power switch. I'll explain that elsewhere in this video, but there is no power switch on the radio. So we're going to be treating it like a regular Raspberry Pi where it doesn't have a power switch. Now the second rule that I'm going to violate, and this one, if you got some good connectors, feel free to use them. But in this particular case, I don't have that. And so what I've done, I've threaded my power input connector through our electrical holder, electronic component holder. And I got to get it back out again. Here's the nut that goes on the back of that connector, and then these are the 2 wires. Now what I'm going to end up doing, I'm going to route these wires through here over to the power supply or DC to DC converter, which goes here, and then I'm going to solder on my 2 wires. That in effect means that in order to service this or this, you have to unsolder the wires from here. You know, we could put connectors there, but I don't know. I seriously doubt I'll be servicing this or this anytime in the near future. So it's not the best solution, but it's the one we're going to go with. So what I'm going to do now, I'm going to get my nut threaded up inside here and get that attached onto here and get that snugged up, and then we'll continue on with the wiring. It's going to be really hard to see, but once you get the nut started on here, you don't need to get a tool down in here. The width of that area should be just about the size of the flat of that nut, so you can just screw this part up until everything becomes tight. Of course, it's kind of hard with these wires flopping around. After verifying that my red wire is the center terminal, meaning it should be positive voltage, I'm going to connect the red wire to the input positive and the black wire to the input negative on the DC to DC converter. Now we can go ahead and mount the DC to DC converter with 2 3 millimeter by 12 millimeter long screws, machine screws, and we'll be using 3 millimeter captive nuts on the back side. Now these 2 wires will go over to the amplifier, and as you can see, these 2 wires come right back to the connector. These are the output from the DC to DC converter, and they will come over here to the Raspberry Pi and connect to the GPIO. Now is probably a good time to install our bulkhead USB to USB cable. So that just gets fed through the back side. Feed it up through there. Line it up with the holes on this side. And you're going to use the included screws that came with your cable, which should be 3mm by 8mm long. And I believe we'll just pull this one out this way for now. The amplifier is going to mount in this location, and because of this volume adjust trimmer pot, there won't be a screw here. So you'll need 3 2.5mm by 12mm screws and 3 2.5mm nuts. Of course, the nuts are captive, and you just flip it over and press them in the little hex-shaped holes on the back side. Now we can hook up our 12-volt power to the amplifier. Of course, make sure you hook up your positive voltage wire to the positive input. Again, this should be 12 volts coming in, because here it branches off the main power input. The Raspberry Pi is going to mount in this location with 4 3mm by 12mm screws. Now you can use 2.5mm, that way you don't have to drill out the holes on your Raspberry Pi. So it's 2.5 if you don't drill them out, and 3mm if you do drill them out. So we just put those in and snug everything up. Now at this point, you can probably route your USB cable back through the housing, coming out this side and plugging in to one of your USB ports over here. Now is a great time to set the voltage on your DC to DC converter. We've got 12 volts coming in at this side. From here to here, we want it to end up being between 5 and 5.1 volts coming out at the output side. Now we do it now before we can connect it or have any way to connect it to the Raspberry Pi. When we finally go to hook it up, we can do it with a little bit of confidence that we've got the voltage set correctly. So what we're going to do, we will adjust this to about 5.1. We'll have to revisit this again after we have it fully powered up and all the load there on everything, you know, with the amplifier driving some audio and the Raspberry Pi powered up and so forth, because that'll certainly change a little bit. So right now we're just under 5 volts. I'm going to give it a little bit more and we'll call it good for now. We'll adjust later once it's fully powered. There we go. Well, that wraps up this video segment. Hopefully you got a good handle on all the electronics assembly. Really wasn't too complicated, just some wires, some basic components, and a little bit of assembly work. The circuit boards, again, try to make those as simple as possible so that anybody can do it. Thanks for watching, and I look forward to seeing you in the next video.